Hello and welcome to this course. In this session we are going to discuss about a new data type, that is array. So let's start. Now what is array? Array is basically a kind of data structures that can store a fixed size sequential collection of elements that is of same type. Here is an example. Now let's talk about array declaration. To begin with, like other variables, an array needs to be declared so that the compiler will know what kind of an array and how large an array we want. So in our program we have done this with the statement int marks 30. Okay, now this 30 is the size. That means it will be going to store 30 values of marks. Okay, next is accessing array elements. Okay, now once an array is declared, let us see how individual elements in the array can be referred. Now this is done with a subscript, the number in the brackets starting from 0 following the array name. Okay, now this number specifies the element's position in the array. Okay, so if you see the second for loop, that is for I is equal to 0, I less than equal to 29 and I plus plus, we have sum equal to sum plus marks, and within bracket there is a value written I. Okay, now this is from 0 to 29, which is the index value for array. So basically marks of I will point each element starting from 0 to 29 that will be stored in this array of marks. Okay, now entering data into an array. Now in order to enter the data into array, the array name with index is used as simple assignment. Okay, you can see here example, like if you want to store 67 in fourth index, then we'll write marks within bracket 3 equal to 67, and this index 3 denote the fourth element. Okay, because the index is starting from 0. Okay, similarly we can read the data from array. Okay, so in order to read the data from array, the array name with index is used and we can store it to a variable. Okay, like example, value is equal to marks of 3. Basically this program is used to demonstrate how we can store the data into array and how we can access the array elements. Okay, so you will see the first for loop, that is for I equal to 0, less than equal to 29 and I plus plus. So we have printf the enter marks and we are storing the value in the array declared for marks. Okay, in the second for loop, the elements of the array is accessed and added to this variable sum. Okay, and finally we have calculated the average, which is sum divided by the total number of elements, that is 30. So this is the basic code to demonstrate the array declaration, accessing array element, entering data into an array, as well as reading data from an array. Now let's talk about some more related to arrays. Array initialization. Now following are a few examples that demonstrate how to initialize an array while declaring it. Okay, so in the previous slide we just see int marks with size. Okay, so we have not assigned any value to that, but we can do so during the declaration. You can see here like int num having size 6 and having these values like 2, 4, 12, 5, 45, 5. Okay, so these are 6 values that will be stored in this array of num. You can just assign all the values within curly brackets separated by comma. Similarly, it is not necessary to mention the size of the array. You can just keep it blank also, like int n, simple square bracket without any size. You can pass as many elements as you want and it will automatically denote that much size. Okay, similarly you can declare array for different data types, like here we have declared for int as well as float. Note the following points carefully. Till the array elements are not given any specific value, they are supposed to contain garbage value. Okay, so the very first thing, like if we have declared only the array and we have not defined the elements, then it will be having a garbage value. Okay, now if the array is initialized where it is declared, mentioning the dimension of the array is option, as in the second example above. As already discussed, like mentioning the size of the array is optional. Okay, next thing is array elements in memory. So whenever we declare an array with size, that required bytes immediately get reserved in memory as shown here in the tabular method. Like suppose we have defined int array of size 8, then let's suppose this is the starting address for this array and their corresponding 8 bytes of memory will be reserved for this particular array. Next is very important thing, which is bonds checking. Now in C, there is no check to see if the subscript used for an array exceeds the size of array. So the data entered with a subscript exceeding the array size will simply be placed in memory outside the array. So probably on top of other data or on the program itself. Let's take an example. We have a main function and we have declared an array of size 40, that is int num of 40. Now what we are doing is we are assigning the values for I equal to 0, I less than equal to 100, I plus plus, num of I equal to I. If you will see here, the size is defined here 40. From 0 to 39, it will store the value of I. But after that, it will start storing the data outside this memory, okay? Or on top of other data. So might be other memory data will be corrupted. So we are responsible to see that the array should not go beyond its size, okay? So it is entirely the programmer's botheration and not the compiler, okay? Because compiler will not going to check whether this array is going out of the memory or not. Now let's talk about array to function, that how we can pass array to functions. Array elements can be passed to a function by calling the function by value or simply by reference. If you remember the example of call by reference and call by value, we have defined a swap function, right? So similarly, these are the examples that demonstrate passing array to a function, okay? So here is a function display in both the cases, and we have defined an array of marks with values like 55, 65, 75, 56, 78, 78, 90. In order to display these values, we can simply pass elements of the array one by one, okay? So this is the example of call by value, okay? So in call by value, we are passing an individual array element at a time to the function display and getting it printed in the function display. The element is collected in an ordinary integer variable m in the function display, okay? That means this is an ordinary variable, integer type m. M will copy the elements for each index and just simply print that. But in call by reference, we are passing address of individual array. So here you can see we are calling the function display. So as we are using address of operators, so simply we are passing the address. And since in the display function there is a pointer variable, so it just receive the address and print the value present at that address, okay? In call by reference, we are passing address of individual array elements to the function display. Hence the variable in which this address is collected is declared as pointer variable, as you can see from here. Now let's talk about pointers and array, how these things are related, okay? Now when we declare an array, then it points to the starting address of that array and the successive elements of the array is placed according to the address and size. Suppose we have an array num having the value 24, 34, 12, 44, 56, 17, okay? In the memory, it will be located as shown below, okay? Let's suppose the starting address of this array is 65512. Since it is of integer type, so each memory location will be of 2 byte and placed according to address and size. So you will note that the array elements are stored in contiguous memory and each element occupying 2 byte since it is an integer array. Now if we write a program to read the address as well as elements of this array, it will be as shown in the example. So we have defined the array, that is int num having these values, and we have just defined a for loop which is running from 0 to 5. We are printing the address as well as value of elements. So this method of accessing array elements by using subscripted variable is already known to us. Now this method has in fact been given here for easy comparison with the next method, which access the array element using pointers. So in the next slide, we'll see how we can use pointers to access the elements. So here is the example. We have the same array. We have defined a variable I and a pointer variable j, where j is having the address of the 0th index of this array. So in this program, we have collected the base address of the array, that is the address of 0th element, using the statement j ampersand num of 0. Now when we are inside the loop for the first time, so j contains the address 65512. If you remember the previous location memory map, 65512 is the 0th index. When we entered in this loop, the j will having the first index address, okay, and the value at this address is 24, okay. So these are printed using the statement. So we have just printf the address that is stored in j, and we have printed the elements by value at address operator. So pointer j will just print the value at that particular address, and after that we are incrementing j. So on incrementing j, it points to the next memory location of its type, that is location number 65514, okay. But location number 65514 contains the second elements of the array. Therefore, when the printf statements are executed for the second time, they print second element of the array and its address, okay, that is 34 and 65514. So you can see the output of this program would be address equal to the corresponding address and element equal to the elements at this particular address. Now accessing array elements by pointer is always faster than accessing them by subscript method, okay. So if you really want to speed up your code, you can use pointers, okay. So that's all for this session. In the next session, we'll just implement these example codes one by one. So if you feel any doubt related to array, feel free to reach us, okay. So see you in the next session.